some more examples based on inequations, and this time in place of the replacement set we are given that x belongs to real numbers. Now there is a different procedure when you are given x belongs to real numbers, and that procedure applies in your solution set as well as to your representation of that solution set on a number line. How? We will discuss that. Let's first solve this. Since we have x on both the sides, what do? We will shift the smaller one towards the bigger one and shift this one to this side. We will get 3 minus 1 is less or equal to 3x minus 2x. So 2 is less or equal to 3x minus 2x is x. What does that mean? That means x is greater or equal to 2. And at the same time, x is a real number. Now we have learned how to represent win on a number line. Win means whole numbers, integers and natural numbers, by placing a dark dots on the numbers, whichever is their solution set. But there is a different procedure for plotting the real numbers on the number line. So we will call this real number as a river. Why? Because this includes real numbers, include all the numbers. It includes whole numbers, integers as well as natural numbers, everything, rational numbers, everything is included in the real numbers. Now, as I said that the solution set is also represented differently as we represented when we had win. What is the procedure? We write always this solution set for the real numbers in the set builder form. And what is that? X such that x is greater or equal to 2, comma, x belongs to R. Let me write it properly over here. Solution set for this is to be written in the set builder form only, comma, x belongs to R. This is the solution set for representing the solution when x is given equal to real numbers, means when x belongs to real numbers. Now the question is, how do I represent this on a number line? Now a straight line, arrows on both the sides. If x is greater than 2, then all the numbers, all the real numbers which are greater than 2 will fall here, right? So let me write 0, 1, in fact minus 1 here also, 2, 3, 4. There's no end point to this. It will go on. X is greater or equal to 2. Now there are two ways of representing this. I'll show you both the ways. The first way is that if this equality sign is also given, and look at the number is 2 here, go to number 2, place a straight line. Why this straight line? Because equality sign is given here. If this equality sign is not given here, we'll place an arc over here. That also we will discuss, but for now we will remember that when equality sign is also given, we will place a straight line. Fine. So it starts from 2. Now we don't know the end point because it's infinitely going on this side. So we will draw a line like this, make an arrow here and shade that arrow, right? This means that we have represented x is greater or equal to 2 when x belongs to R. Another way of representing this is, again you take minus 1, 0, 1, 2, 3, 4, 5. Now x is greater or equal to 2. Now equality sign is there. Go to 2. Okay. Place a dark circle. Now if this equality sign would not have been there, we will place a simple circle here, not the dark one. Now since equality sign is given, so we will place a dark circle over here. And then since this is infinitely increasing on this side, so we will darken this side, this line. We are darkening this and darkening this arrow also. And this should be visibly clear than this arrow. What does this mean? This means that you have represented x is greater or equal to 2 and x belongs to R. Both these methods you can use. You can choose either of the two. Both are correct. Okay, let's go to this equation. Now here on both sides of the inequation you have only one term. So we don't need to take the LCM. We will cross multiply. 2 5s are 10x minus 16 is greater or equal to 4 3s are 12x minus 21 and x belongs to R. So x on both the sides. So we will shift the smaller one to the side of the greater one and shift this 21 here. 21 minus 16 is greater or equal to 12x minus 10x. So this becomes 5 is greater or equal to 2x. Does that mean 2x is less or equal to 5? Does that mean x is less or equal to 5 by 2? Does that mean x is less or equal to 2.5 and x belongs to R? So how will we write the solution set for this? We will write it in the set builder form. X such that x is less or equal to 2.5 comma x belongs to R. And now the representations will try both the methods here. Now x is less or equal to 2.5. So what does that mean? We will go to 2.5. If this is minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Where exactly does our 2.5 fall? Here, right? We'll go here. We have x less or equal to 2.5. So equality sign is there. Place a straight line here and a straight line like this and then an arrow like this. Now shade this. This represents that infinitely it's going on less or equal to 2.5. From this side it's going to this side. If I have to represent this by another method, again I'll go here. This is my minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Now I have to go to point 2.5. Equality sign is there. I'll go to 2.5. Place a dark circle here. And from there I'll darken this line. It should be visibly darker than the other portion. And also darken this arrow. This is another way of representing x is less or equal to 2.5. Right? Now, another method. In this inequation, you will see that you have two inequality signs here. Fine. So, how do we solve it? We divide it into two parts. First, we will take this part. Minus 3 is less than 2x minus 1. This is my first part. And what is my second part? 2x minus 1 is less than x plus 4. Let me solve these two parts separately. You see, minus 3 is less than 2x minus 1. This was my first part. Then 2x, this middle term, has to be taken twice. First with this minus 3 and second with this x plus 4. I have taken 2x minus 1 first here and here also. Here also. Okay, let me solve it. Minus 3. I'll shift this to this side, becomes plus 1 is less than 2x. It means that 2 is less than 2x. Does that mean 1 is less than x? Let me keep it as it is. Let me go here. Again, I have x on both sides of this inequation. I'll shift the smaller one towards the bigger one. 2x minus x is less than 4 plus 1. So x is less than 5. Right? So if we combine these two solutions now, what will I get? 1 is less than x, but x is less than 5. Right? So what will be my solution set now? Since my x is integer, I have to choose it from the integers. So my solution set will be a roster form. All the integers between 1 and 5. Since there is no equality sign here, so we will not include 1 and 5. We will include all those numbers which are lying between 1 and 5. What are those? 2, 3 and 4. This is my solution set. Now, I know how to represent it on a number line. Simple. Place 2, 3, 4 in the middle. 2 more numbers after 4, 5 and 6. 2 more numbers after. Go to 2, 3 and 4. Place the dark circles because this is win. This falls in the category of win. Right? Let's go to this equation. Again, we have 2 plus 4x is less than 2x minus 5 is less than 3x. So we will take it in two parts. 2 plus 4x is less than 2x minus 5. This is my first part. And my second part will be 2x minus 5 is less than 3x. Let me solve them in two parts. So shift this 2 to this side and this 2x to this side will make it 4x minus 2x is less than minus 5 minus 2. So 2x is less than minus 7. So x is less than minus 7 by 2. Let me leave it there only. Go to this part. Shift this 2x to this side. Here I am left with minus 5 is less than 3x minus 2x. So minus 5 is less than x. Right? Now minus 5 is less than x is less than minus 7 by 2. Let me combine the two solutions. Minus 5 is less than x, which is further less than minus 7 by 2, that is 3.5. So my solution set for this will be, let me check, it is integers. I have to choose the numbers from the integers. So which are the numbers between minus 5 and minus 3.5? Which integers are there? Only one. And what is that? That is minus 4. So how do we represent this on the number line? Minus 5, minus 4, minus 3, minus 2. Go to this, place a dark circle over here. That's how it is.